Hi again. Okay, so now we're going to start talking about conservation of mass, right? So let's write it. Conservation of mass. Okay? Now, I want you to understand that when we are looking at chemicals, or pretty much anything that you can count, there's two ways to count how much stuff there is. Okay? The first one is you can actually take the stuff, put it on your hand or put it on a scale and measure the mass of this thing, right? So just like a bathroom scale, you'd put this on a scale, you'd say, oh, there's 110 grams of this, that's how much mass I have. The second different way to find how much stuff you have is to actually count the stuff. So I have 2 pieces, 3, 4, 5, 6, and so on, and count them up. And I don't know how many it would work out to, but let's say it's 18 pieces. I have 18 pieces. I counted the stuff. So I can find the mass, or I can find the number of individual things, okay, by counting. Okay, well, the same thing works with chemistry, right? So we're going to look here, and we have our C2H2 from last time, the last video. That's 2 carbons and 2 hydrogens, 2 carbons and 2 hydrogens, because there's 2 of them. And then I have 5 O2s, right? So there, there, and there. Okay, 1, 2, 3, 4, 5 pairs of oxygen. Okay, so now we said when a reaction happens, these all break apart and recombine in a different way. And what you need to learn in this lesson is that the mass of stuff I have here, if I put it on the scale and I have 110 grams, once I take it all apart and put it together in a different way, I should still have 110 grams of stuff, right? None of it, I didn't hide any Lego pieces and I didn't add any. That's what the rule, what the law of conservation of mass says. Mass isn't created out of nothingness and it's not destroyed. It's conserved. It stays the same within a certain system, okay? The other thing you should also see is that if I break this apart and recombine it, I should have the same number of pieces. So conservation of mass works for the actual grams, the mass. It also works for counting, okay? The actual particles. And that works even when we draw them, right? So if I look at the particles, I have 4 carbons, and here they became 4 separate molecules, 4 carbons. I have 4 hydrogens. Well, those went over here to become part of the H2O. There's 2 of them. And I had 10 oxygens, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 oxygens. So the particles were conserved, and so should the mass be. Okay, so, I mean, at the end, maybe I'll go through the trouble of rearranging these again. But now the particles are conserved, and you should see that. What about the mass? Well, now we're going to get to test stuff. The mass, if I give you a question and I say there's 52 grams of acetylene, where are we here? Yeah, 52 grams of acetylene and 160 grams of oxygen, and you did the reaction and got 176 grams of carbon dioxide, how much water did you get? How do you find that? It is very simple. Students tend to look at this and think, oh boy, it can't be that easy, and they make something much more complicated and get it wrong. So this is the reactants. How much do I have? I have 212 if you do the math or punch it in your calculator. And here I have 176, right? So how much is here? How much out of the 212 that I started with, and some of that became CO2, 176 became CO2, the rest must have become that. So the answer is 212 minus 176 equals, let's see my math, 24 plus 34, 36. 36 grams H2O is my answer. It is literally that straightforward. Please don't overcomplicate it. Okay? You take all the product's mass, you subtract whatever you have to get what's missing. I could give you the problem a different way. For example, I could give you, oh, let's do this slightly differently. I'm going to say, instead, I don't give you this number, but I do give you, I say, oh, 36 grams of water were produced out of 52 grams of acetylene and some oxygen. How much oxygen did you need to make this much stuff? Same idea. You would add these two together. So 176 plus 36 is 212. And then I have 52 plus something must equal 112. So I would subtract 212 minus 52, and you would hopefully get 160 grams of oxygen. So it's straightforward. Don't overcomplicate it. Okay, so to sum up, mass is conserved in two different ways. Mass is conserved according to the number of particles, the actual atoms, right? If I count the actual C's and H's, C's, they must match at the end. The H's must match at the end over here, and the O's must match at the end. The conservation of mass also works for mass in grams, because if I find the mass of this stuff at the beginning and then I rearrange it, I still have the same amount of stuff, so the mass should be equal. When I am doing the grams conservation of mass, I am adding the products and adding the reactants and just subtracting them to get whatever is missing. I do not use the big numbers, the coefficients, for calculating the mass. Okay? If I tell you I have 52 grams of eggs and the recipe says you have to have 2 eggs to make a cake, it doesn't matter how many eggs you need to make the cake, you have 52, and the 52 grams went in the cake. Ignore the big numbers. Okay? How do you study this stuff? You practice it. Practice it over and over and over. And the beauty of this stuff is that the particle model, you know if you got it right, because you can just count them and they have to equal up on both sides, and the mass has to equal up on both sides. The mass has to equal up on both sides. Okay? So remember, practice, 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 and you'll do great.